The technical roadmap, the way we see the road ahead where we stand today in 2008. But maybe first, a quick look back at the last couple of releases. Version 11, you may remember, that's nearly 2 years ago now. We introduced object orientation, added classes. How many people here have now written a class? Okay, well it's catching on. That's very encouraging. We didn't expect everybody to rewrite everything as classes, and probably a lot of analytical code really has no benefit from classes. But there are a lot of situations where when you start thinking about building components and interfacing to other languages in particular, it's very useful. And then there are a bunch of problems where we think it's actually valid as a tool of thought, not just as an encapsulation mechanism. It allowed us to significantly improve the integration with .NET, and it allowed us to start thinking about doing source code management in a different way, which we think is going to be very significant, particularly as we bring more of the young users into the community. 64-bit version, as Gitta mentioned, and a couple of core language extensions to prevent us from getting Alzheimer's. Learn some new tricks at that level as well. Version 12.0, we can say we're looking back at that now. How many people have fired up version 12? Oh, very good. That's for Windows, it's been out since February. The main features there, of course, Unicode support is the big one. Journaling component files. Well, the 64-bit version attacked one of the most hated error messages, workspace full. And journaling component files attacks probably the most hated error message of all, which is file damaged. With journaling component files, that should hopefully soon be history, that error message. There is a simplified communications toolkit. We think working with TCP-based communications on the internet is getting more and more important. And we've done some work to make that significantly easier for APL programmers. There is the Causeway tools for charting and document creation, and the language bar and on-screen keyboard you'll see in a moment, those of you who haven't seen it already, which is, again, something aimed at bringing new users into the community, making it easier to get started with APL. And now, as we are back in the fall, most of the platforms now have version 12 available. So Windows, both 32 and 64-bit, are available. The same for Intel Linuxes. AIX, we're still waiting for the 64-bit release. Windows Mobile will be available at the end. We're aiming for the Christmas shopping window there. And Solaris, other versions, we're waiting for people to really tell us that they want to go to Unicode, for example, on those platforms. There are a number of presentations at this conference where you can learn more about version 12 in particular, also version 11. So this afternoon, Richard Smith, not the Richard Smith that you've seen before, but our most recent recruit. There are 2 Richard Smiths at this conference. And Richard has hit the ground running and is working on journaling component files, and we'll be presenting those with John this afternoon. If you want to learn more about Conga, secure sockets, web services, I'll be doing a tutorial on that tomorrow afternoon. Adrian did workshop yesterday. He's doing a tutorial on Tuesday on RainPro. Source code management, Dan did a workshop yesterday, and he's repeating that on Wednesday afternoon if you want to learn more about doing source code management based on Unicode text files. And Unicode support, unfortunately, my workshop was yesterday. If you didn't see that, there's no opportunity to see it again. But I'll do a very short demo now, just to cover this will cover both the Unicode and some of the recent features in version 11 as well. This is my favorite Unicode demo. Because one of the things, Unicode has everything. It doesn't just have Chinese and Japanese and Korean and Bulgarian. It also has chess pieces. And that allows us to just, if you have the right keyboard, of course, for typing chess pieces. I don't know if there's a chess keyboard available. Probably there is. I haven't found it yet, but you can easily cut and paste them out of a web page somewhere. If you find a web page with chess pieces on it, probably you can just cut and paste them into a Unicode session without further ado. So here are some variables that I use to set up, give us the order that the offices are arranged. We have two colors. And then with a null.catenate, we can create the indices. So we can say, well, first we want the black rook and then the black knight and so on. And we can we rotate the indices for the white pieces because the pawns come first, and we have our array of chess pieces. We can expand it, of course, which fills it with spaces. And we can now do we can do computations. Board plus dot equals white pawn counts the number of white pawns on each row of the chessboard. We can create a form and put a grid object in where we just put that array board, which contains the chess pieces, in as the data in the grid, and then set the width so that it looks a bit nicer. We can put say we're going to play chess in Greece, we can put Greek labeling onto the chessboard, create a couple of background colors and a checkerboard pattern, and we're ready to go. And of course, and to not irritate the Latins, we'll put in some Roman numerals down the side. Okay, so we can now treat all of these characters just like the characters that we're used to. And so let's do a little bit of arithmetic here. There's a bug. I'm usually worried about the Russians in the audience, because every time I do this presentation, there's a Russian chess player. Last time it was that I had the king and queen reversed. I looked this up on the internet. I didn't do sufficient quality control on it. I apologize. Okay, so what are the unique chess pieces? Let's do a frequency count of the chess pieces and sort it. So here's an array of the frequency count. Okay, they're most spaces. Put that into an array. And let's show off some of Adrian's stuff. So if you now right-click on that, where you get the pop-up, if you click on the pie chart, wait for .NET Framework to be loaded, we have a chart with the frequency distribution of chess pieces. And, of course, the interfaces to things like Excel also all work for this. So if you're using COM or .NET, you create an Excel object, add a workbook. Okay, I'm going to go really fast here. If you want these examples explained, come see me afterwards. So into the active sheets range A1 to H8, put the chessboard values. Call the auto-fit method on each of the first 8 columns. Get hold of the interior property of each cell in that range. So monadic squad here is a new feature in version 11 that takes a collection as its argument and materializes that as an array in the workspace. So we get those 64 cells as a vector. And then the interior has a property called color, and if we get hold of the chessboard background colors indexed by the cell types, do the base 256 decode of that, we get the number that Excel wants to see to color those cells. Okay, then we'll move a piece, move the pawn forward, put that into the second sheet, move a knight, put that into the third sheet. On those two sheets, the first 8 columns call the auto fit. So that made 16 calls to auto fit methods in different columns in 2 different sheets. Okay, so here are the names of the sheets. Extract the sheets collection. Set the names to the different moves. And then, so if we click on one of these now, we can see that this is what the board looked like after moving. Yeah, very useful application, clearly. And then we can extract the sheets, indexing them by the names of the sheets, and get the center cells for those 2 sheets. Or we can just say, well, get the used range for all of the sheets, get all of the data out as a 3-element nested array. So that sort of covers Unicode and arrays of objects, the class extensions in version 11, very briefly. So that's what we've been doing. This must be Office 2007, Gitter. See, it gives me a little button to press. Okay, so if I'm not going to read this up, I don't have time, but as you can see, the team this is just going back to 1998. And if you look at these, there's some very significant things, multi-threading, OLE automation, .NET support. There is a massive amount of work that has gone into recent releases of Dyalog APL. The product has really developed at a breathtaking pace for, I think, all of its 25 years of history. Now we've grown a bit, and looking back, features for each release, I think it's true to say, I haven't been here all of the 25 years by any means, but I think generally, very often, we've researched and prototyped and released features in a single cycle every time. And that does make it a little bit of a challenge to ensure quality and to predict release dates when you're doing research as part of putting out the next release. So what we're hoping we can do now, having grown the team a bit, is to become more predictable, but without losing momentum. And for version 12.1, there are going to be very few visible changes, because there's a transition period where we need to change the way we do things and clean a few things up. So we've already moved all of our source code into Subversion. We've been changing the way we do development internally to develop all of the different platforms much more in parallel, do QA, interop, sort of as we go, rather than doing it after we released the Windows version. So the theme for version 12.1, we say, is enterprise applications, but you shouldn't have to be an enterprise to benefit from this, because things like performance, scalability, quality, and reliability, I think, are things that everybody enjoys. So we're going to be working on a lot of internal changes to how we do things. We're going to be polishing off some recent features. So we've added object orientation 2 releases ago, but our IDE now, we're getting some feedback from users that say, well, it's not really as easy to use as editing functions, where the IDE has been tuned for 25 years to become really good at doing that. We need to provide better support for namespaces and class scripts. We want to do more work on Unicode. I keep saying this, Unicode-based source code management. I think it really is significant going forward. And in addition to mostly performance and quality work on 12.1, we intend to start some research projects which are actually targeting subsequent releases, so that when we get to the next conference, we'll have a bunch of things where we've already done significant research that we can tell you about, and have a much clearer idea of what's going to be in the next release and when we can make it available. So what's guiding our design? we see the following platform trend. So the proprietary Unixes are fading. AIX. And how many people here use Solaris? Jeff doesn't count. Okay, yeah. So AIX is stronger, at least in the APL community. And we don't see AIX going away anytime soon. But clearly, things are drifting in the direction of Linux or Windows, in fact, as a production platform. Some of you may have trouble believing that, but it's definitely the case. Windows is maturing and remains the most important platform as far forward as we can see. 64-bit is everywhere in Unix and Linux, and even the Windows users are starting, it's single digits, I think, in percentages, but people are starting to use 64-bit Windows. People want to use more memory. And the really important trend at the moment is that multi-core machines, or at least dual, you can't buy a machine that doesn't have 2 cores, I think, these days. So it's hard. And we really have to find ways to make these easy to use from APL. Harness the power of 2 cores from APL is perhaps at the top of the list at the moment. And on the sort of the software side of trends, Microsoft.NET is really becoming a unifying force. Even in open source Linux distributions now, you have components that rely on the open source version of .NET called Mono being available. So desktop components in free Linux systems rely on .NET. So at the software development level, the differences between the platforms are getting smaller. There are more and more common components on Linux and Windows, which means that people are going to want to be more portable, but also that it's easier for us to achieve that, we think. And service buses and open standards like web services are also common on all these platforms. And curiously, this means that .NET is getting more and more important, and at the same time, it's not that important if you're outside .NET, because you can very easily integrate with it. So you can run something under Linux or AIX and present it as a .NET component, interface it to .NET infrastructure, for example. Right, and the philosophy, I think, of us and very many of our users, the most successful APL coders, the domain experts, unlike people who studied software engineering and see that as their key skill, they have no wish to recode their application to adapt it to the IT flavor of the month every time there's a new one. The software people love that because that's what they train to do and they're good at. And refactoring and so on is something they enjoy. But the domain experts want to do rapid development, and then they want ultra long-term maintainability. I mean, we have many customers here who have applications they've been working on from before Dyalog, before Dyalog APL was on the market. So maintainability and portability is very important to our customers, and that's why we've put huge effort into the Unicode version, making it as easy as possible to migrate. No big bang migrations of data. Interoperability across platforms and versions is very important. So an APL workspace should be loadable. Save it on Pocket PC, load it on 64-bit AIX, and the application runs, unless it's using some funny widget on the Pocket PC, of course. But and despite these constraints, which I think Dyalog has always seen, or Dyadic has always seen this as very important. I don't know how it was done in the past, how you had the vision to see where things would end up. But despite these constraints, I think the integration that Dyalog has with various components is better than the competing products on the market. Maybe it's the constraints that make you good. It's the discipline that makes you strong. Yeah. But it's looking easy. These goals are getting easier and easier to achieve, we think. Okay, so what are we looking at right now? We have actually started looking at exploiting multi-core architectures. So both within the interpreter, use several cores to execute a single primitive, and mechanisms for allowing the user to decide how to fork. We are working on providing a web service framework so that any APL application can easily present itself as a web service without requiring IIS or Apache or anything. You can integrate with those if you want, but you don't need them. Just start your APL application, hook it up as a Windows service so that it restarts when Windows boots, and your APL code is available to the world. So the likely research projects that we might start in the next release cycle, we think the time is near where we should completely rewrite the development environment, not to change its functionality, because we think it's a very good development environment. But we think if we rewrite it based on .NET and Mono GUI components, we can then, it's trivial to port it. In fact, Microsoft would claim you don't have to rewrite anything. It just runs on a Macintosh without us changing a line of code. Because Mono is available on the Macintosh. And Mono will be available on your refrigerator. And then not only does that then allow us to more easily port the core interpreter, but we don't actually have to make the IDE available on the same platform where the interpreter runs. So we could do an IBM mainframe Linux port without having to think about how we provide an IDE on the system. What is it called these days? 390 something. So this IDE can connect. So you can run something as a service unattended, and then when you discover it's failed, you fire up the IDE, you connect to it to do remote debugging later if you have the necessary privileges and so on. We think we want to extend the .NET bridge so that APL developers can also use Mono to develop GUI. That's related to but independent of the IDE. Where we provide the IDE and where the applications run their GUIs is not necessarily the same thing. We think we also have to bite this bullet soon and design and implement a prototype of a managed APL interpreter. How many people here know what that means, a managed APL interpreter? Okay, the smallest number of hands so far. Managers will insist that you have one of these. They have absolutely no idea what it means. It means an interpreter that runs on the .NET virtual machine, so using the data types that .NET runtime provides. And that allows you then to run Dyalog components in these sort of secure sandboxed environments, like inside a web browser, inside SQL Server as a stored procedure, and so on. And we need to do more research into using multiple cores. We can see this is a long-term thing if we really want to take advantage of this. For example, we may need to do look at the kind of things that Bob maybe can help us with. Data flow analysis on APL expressions, because that's important in really using multiple cores, we've found. You may remember I mentioned this project earlier, the file acceleration server. So that's like the share file system, or the Sharp APL file system that you used to be able to run as a separate component and connect to over the network. We think there is still a need for this, but at the moment there are just other things that have pushed it down a bit further on the stack. If you think you really need that, please come and see me and we'll talk about moving it up. So a little bit more about this. So a managed interpreter, we don't think, cannot be a replacement for the current Dyalog system. So we're not saying, the Dyalog APL system that you have today will die and there will be a new one based on the .NET runtime. A new APL which really uses the .NET framework cannot really be 100% upwards compatible, even at the core language level, because .NET insists on various rules related to passing things by value and reference and so on, which mean that if you try and really stick to APL as it's defined today, you can't really be a first-class citizen of that universe. And there's no point putting an APL interpreter there unless it really is a first-class citizen of that. So we think, at least initially, this is something that some of our users will use for specialized applications, building these little components that they need to embed in web servers or other frameworks where managed code is a requirement. But it's certainly going to be a very long time before we imagine that, Dyalog, the current unmanaged system, would go away. We're talking decades, not years, before that might happen. It may eventually become the preferred system and the old one will fade away. But we would not, under any circumstances, reduce our investment in the current product while we do this research project. What we think is really important for moving forward, for you to move forward with this, is that a new IDE would work both with the current and the new APL interpreter. So you'd have two APL systems which were slightly different, but maybe you could trace, as you go call a function from the old one into the new one, the IDE allows you just to trace straight through it. So you have a seamless working environment, ideally. And you need to be able to write and maintain systems composed of components from both of these systems. Another sort of two-pronged mantra that we have. Now, it's very important to us. All of the big customers want us to do this. Have to write components that can be embedded in enterprise development frameworks. But we must never forget that at the root of every APL application was this person in a garage with a friend who maybe knew a little bit more about programming. We have to all the time make it easier for the lone entrepreneur or domain expert, maybe two people, to build a complete application without learning how to use Visual Studio or Eclipse or some massive framework in order to write an APL application. You should also be able to use those frameworks, but they must never become the only way you could do this. In addition to work on the interpreter itself, we think it's time that there's been enough development in the frameworks that we should take a new look at providing some simpler tools for building GUI and web applications. We'll probably prototype these in APL like the web service framework. One question which we're struggling a bit with now is, and we have Causeway Pro. How many people here use Causeway Pro? It's a relatively small number. How many people know what it is? Okay, so why are you not using it? I mean, there are very many reasons why people don't use it. I think a lot of the big customers here have built their own, complete frameworks which manage the whole workflow from project management through to designing the GUI and the database. The metadata for the database is all rolled into one application. You very often see that at APL sites that have been working for a while. But I think a tool like Causeway Pro, as we have new people coming into the market, is perhaps much more relevant than it used to be 5 or 10 years ago. So we're thinking, maybe we should shine this up so it can work with .NET and with Windows Presentation Foundation or whatever, and asking Adrian to do an overhaul of that. So that's one thing I'd be interested to get some feedback on this week. And we want to, in general, do much more work in collecting these code patterns and so on that Gitta was talking about. General purpose developer tools, frameworks. For example, one of the buzzwords in the Agile community is, using tests to drive the design and development and refactoring of your applications. Yes, I think everybody, my experience certainly now writing applications is I don't dare write applications anymore without a suite of tests, because then I don't dare change them. Without a test suite, life gets too dangerous once you go into production. And to be taken seriously, if we go out and say, well, we're agile programmers, if we're not doing this, and say, well, you can't be. because you can't do the refactoring and so on, which is an important part of being agile, without test-driven development. Yet. No, but we need to work on that. We think it's important. Okay, so in version 12.1, perhaps the only really visible thing that will be in version 12.1, as we see it now, is that there will be some IDE, there'll be some enhancements to the editors. We're already looking at, and John Daintree has a presentation right after lunch showing some ideas that he's been working on to enhance the IDE to make it better at editing classes and namespaces. It's looking really, really cool. We've been talking about this for a while, better access to .NET metadata. For example, that you can, in a session, highlight a piece of code and ask the interpreter to evaluate it and autocomplete. So find out what .NET object is the result of this expression and then provide autocompletion for it. And look at the performance of moving data between the .NET framework and the unmanaged APL interpreter. But performance, which is sort of invisible, is going to be the main thrust in addition to just work on stability, more testing, and QA. And we have a number of things we're working on there. We, in addition to our own permanent staff, we've been working with the gurus. We had Bernanke doing some work for us last year on research into how we might reorganize the memory management in how we manage the workspace. We haven't actually been able to put that into the product because it requires a bit more refactoring of APL than we were able to do. But Roger has done some work for us on Boolean scans and reductions, which is much easier to just plug in because you're just sort of replacing the code for individual primitives. And really speeded some things up. So if you want to hear more about that, Roger will be talking at 2:15. Indexing and index assignment. We've had people complain that indexing consumes far too much space. Not that it runs slowly, but it uses too much workspace. So Nick has already rewritten indexing. I think indexed assignment, is that? Where's Nick? Not yet. No. But if you want to hear more about that, there's a presentation on that this afternoon. We know that there are more things we could do on set members. Dyadic IOTA is the classical hotspot in many large APL applications. Looking keys up. We have ideas for various other primitives. And we've been doing this experiment on using multiple cores. Okay, so I'm not going to go into this. There's far too many numbers here. Roger will talk about this, but here are some Boolean reductions and scans. Here's a bunch of different types of arguments. So V is a vector, and then there are various vectors with different characteristics where Roger has rewritten the algorithms. Those that haven't speeded up much are the ones that I think we had already spent a fair amount of time on speeding up. But even those, the smallest number here is 2. And the biggest is 1,500 times faster. Of course, whether that will help your application, your mileage will vary. Because the hard part about work on performance is that although we have lots of ideas and a few clear customer requests, it's really hard to decide what's important. Are those Boolean scans, do they matter? So the first thing we've done is, again, Nick has built a monitor, which if you're using DSS and you recently patched your system, you can start it with this startup parameter -dm, big D, little m, and it monitors CPU consumption broken down by primitive. So it creates a CSV file. This is real customer data. Many thanks to Konak in Belgium for allowing us to reveal these numbers to you. I don't think there's anything confidential there. So this, basically, there's a record here for a token if it was an operator, a left and a right operand, the data types, the ranks, the size of the arguments. These are broken down into ranges. So this means the size of 1. 100,999 means it was in that range. And then how many times that type of call occurred, and the summary of CPU time on that. And then I spent a little time with Adrian's wonderful new, what's it called? IQ. I can import one of these Applemon things into it, and then this is the result of a little query. So you load the file, it shows you the top 10 by default. This is a workspace that we'll make available. So it shows that left bracket, which is the token for indexing, is the top, 20% of the time was spent in indexing. Multiplication was the second one, plus reduction, row transpose, and so on. And then you say, oh, well, times looks really interesting. I want to know more about that. There were 25 different cases of it, and 207,000 calls. You can then say drill and either the name of a token or one of the numbers from the list there. And it says, well, the big scorer was 2 floating point arrays of rank 2 with argument sizes in these ranges. And we can then say, well, you send us this data and say, well, if this function ran faster, it would improve the performance of our overnight batch run by so much. And we can say, well, do we have any ideas for optimizing this case? And then if you're asking for something that a lot of other people asked for, it just gets up to the top of the list. And if your requirements are not at the top of the list, you can join the sponsor a primitive program. Okay, so this is available now. If you want to get the bar graphs, you need Adrian's new Unicode font with the 1/8 width bars, so that you can get the nice bar charts in your APL session. Okay, so one of the things I'm going to run out of time here, but we looked at simply taking the simple primitives plus, minus, times, divide, GCD, LCM, and if the argument size was bigger than 32K, for example, split the task up onto different cores and let them all run in parallel. And what we found was quite surprising. If you run something like plus on 2 cores, it speeds up by 12%. If you run it on 4 cores, it's still only 12% faster. Whereas something more complicated like GCD LCM on divide speeds up. It actually runs twice as fast on 2 cores and 4 times as fast on 3 cores. And our theory about that now is simply that, thanks to Norbert for running this on his Windows server, we have a quad Linux machine and the numbers there are identical. The theory is that the memory management subsystem of the chip simply cannot deliver the data fast enough if you're doing something simple like plus. So if you set 4 cores all off doing plus, they request memory which can't come from the on-core cache if the arrays are big. And all the cores show up on your monitor as running at 100% utilization, but in fact the cores are starved and they're not getting any data. So they don't finish any faster. But this looks interesting for heavier functions. Derived functions, idioms, hashing algorithms maybe, and interestingly in APL, anything involving quad CT is a fairly heavy operation that we think will speed up. But we really learned that measuring and understanding performance is very hard, and learning how to use multiple cores effectively, particularly if you're sharing a machine with other applications, is something we have to work hard on. And really, it would help if we could do compiler-style data flow analysis to allow a core to, if you're doing A plus C times D, load little bits of each of A, B, C, and D, and then have a core do all of the work on that, rather than trying to load everything, do a plus, save it, and then move on to the next thing. Okay, so why don't we let the user decide when to fork instead of us trying to do it? Using multiple cores within primitives is, of course, I mean, that's what every APL programmer expected, right? APL is a parallel notation. When we have multiple cores, it should just speed up by a factor of whatever number of cores you have. But as we can see, that's not the reality. It would be nice to do that, but we have these bottlenecks. And of course, the average size of arrays, if you measure the average size of arrays passed around in APL applications, those CONAC numbers were actually atypical. It's an actuarial application that really is working on very large arrays most of the time. But a lot of APL applications just don't do that. I think Bob did some measurements on Sharp APL time sharing, which showed the average size of an array was 1.7.
Yeah, I think about half of all operations have 0 to 1 element arrays, and about 85%.
0 elements.
Of all operations
Yeah.
were 15.
Yeah.
That was on a multi-user, 1,000 concurrent user system.
Yeah.
All the applications on the system over the course of a month. Let's see. There was also some work done with Massachusetts that provided simple results, and Guide IBM Research did a paper that basically provided similar results.
So we think that. Oh, yeah. Yeah. So in most situations, you will probably get more bang for the buck if the APL developer controls the forking at a higher level in the application. But of course, we need a notation for that, an elegant notation for that then. And of course, APL does have, in addition to the implicit parallel stuff in scalar functions, there are explicit forking mechanisms. In fact, Dyalog has one more than most APLs. All the second generation APLs have each. We also have a dot to the right of an array of namespaces is in fact an each. That is, in fact, that dot is like an operator in many ways. If you have an array of, as I showed with the Excel, 8 columns dot autofit is 8 calls to different autofit methods. Now, due to limitations in the way the interpreter is put together, Dyalog APL can't actually make these calls in parallel inside the workspace. It's not thread safe. The memory manager, and we would have to completely rewrite the interpreter. And it might end up being slower because it would have to do all sorts of interlocking between these threads so they didn't mess up the workspace for each other. But imagine if we had a mechanism to generate namespaces outside the current workspace and a nice notation to deal with that. And this is something I've modeled in APL to begin with so we can play with it a bit. So I have a function here called v13. I don't think we will ever have one of those. This is not the APL interpreter doing this, right? It's a model written in APL. So in Dyalog APL, you can say, give me 2 empty namespaces, and then in each one of those, create a matrix which is invertible. Probably invertible. Okay. Just have task manager here. We can see the fish tank. And then, okay, so if you say nss.rowmat, that says 500, 500, 500, 500, because there's 2 namespaces. Each one of them has a mat in it. And the dot just says, well, run that in both namespaces. And if I say something silly like, first try. Yeah, so multiply the matrix by its own inverse and display the upper left. Okay, now watch the fish tank. So my machine goes to 50% because it's a dual core machine like most people have these days. And it runs for about 18 seconds, I think. Anybody have a good joke? An 18-second joke? 17.6 seconds. Okay, and it did the deal. So imagine we had a system where we had a new primitive called fork, which you could give an argument of 2, for example. Say, give me 2 empty namespaces. And at the moment, what happened there was I started 2 runtime interpreters, right? That took about a second. And each one of those is now actually running what will appear to me to be a namespace. So I can go up here and I can say, okay, remote.mat gets that. Okay, so that set mat in those remote namespaces. And I can say remote shape mat. Yeah. And then I can go up here. And so here, this is it with a drum roll. Watch the fish tank. Way! 100%. So our goal for version 12.1 is to fill the fish tank. 10 seconds. So, yeah, to know what delayed it there. Usually it's very close to half the time. Okay, and if I say, so the way this works is, if I do that again, well, let's just do this one. There's a little parser here which detects that the thing on the left is one of these remote namespace thingies, and then it translates this in dot is a user-defined operator. It translates that into a defun because that's something I can encapsulate and send over a TCP socket. And then it executes it using Conga. And you see the overhead, I mean, this doesn't take, there's no delay here. And you would only want to use this for farming off something that took a serious amount of time anyway. Alexei? What do you mean, step on each other? Yeah. Well, no, that's, I mean, you can't control that. You've got a number of cores in the machine and they get shared. Yeah. I mean, using multi-cores, especially if you've got several applications, you've got dual core, you've got 2 applications that both say, well, I'm going to run multi-core, I'm going to use 2 cores. They don't both speed up 100%. And there's no way to achieve that. Maybe I can't remember what's on the last slide. So when I then erase these, the APL tasks go away. Let me just finish and then we can take some questions because I'm over time. So the arguments to fork could be, create some empty namespaces, a list of reference to instances or namespaces. You then get those encapsulated outside the workspace. A workspace name, create a remote thing from a saved workspace. And the APL models almost all the performance benefits, but not the elegance of the, integration with the interpreter, which would really put parallel execution, I think, at the fingertips of an APL user. An APL user would be able to learn to type expressions like that and harness multi-core without learning heavy machinery again. But we want to wait a bit with actually putting this into the language. We'd like to, with some of the users who really have a need for this, experiment with the APL model and then maybe put it into the language a little bit later. Okay, so I'm now seriously late. There's a conference edition on the memory stick, which has most of Roger's work, the new implementation of indexing, but not yet indexed assignment. It has this implementation of parallel processing on some large scalar functions and 2 environment variables that you can set. So if you could take this home and run it on your multi-core Windows, this is a Windows 32 system, send us some numbers. We'd be very interested to see what sort of numbers you get. We've written a function to show off this interpreter. So here's some quad monitor timings. There's a little bit of noise here, but basically here's something that does a division. It runs twice as fast. We were going to do less than, but didn't make it, so that runs at roughly the same speed. indexing, you can see the speed of this case has gone down. Indexing a Boolean array has gone down from half a second to zip. And here are some of Roger's improvements on the last 3 rows. So here's a function that's speeded up by more than a factor of 2. But of course, it's carefully designed to show things off. So the release notes for version 12.1 will be much thinner than release notes for previous releases, but it will be faster and stronger, and it will look better. And after that, things will get really interesting when some of the research projects are ready to be put into future releases. And there's more about this in these presentations here, but my time is more than up. Whereas Gita has gone, so I can't ask her if there's time for questions. But why don't we just, if people need to wander off and start having coffee, off you go. People who want to stay for questions, I'll just stay here in the break. Okay, thank you.